And we're live. Welcome to the Swift Kick Show, everyone. My name is Kevin Griffin, and I'm joined by my very good friend of like 10, 11 years.
Many years.
Many years. Joel Cochran. Joel, how are you today?
I'm great, Kevin. How are you doing?
Doing well. You're one of our few repeat guests here on the Swift Kick Show, so
Ooh,
welcome back.
I'm like a bad burrito.
Yeah, like a bad burrito, you can't get rid of you. All right, we have a couple folks joining, so we'll let them come in, but we'll go ahead and get started. So Joel, you were at Build last week, right?
I was at Build last week. I'm even wearing one of my Build t-shirts today.
What is that? Is that like a
Completely
Space
coincidental.
Invaders?
It's Space Invaders with disks and servers. We're killing all
Oh
the
my God,
servers because it's all about serverless.
server. But
Ah.
but
So
serverless runs on servers, though. It's
yeah,
just
just
not.
not my. I don't care. I don't care
All
about those
right.
servers. That's not my
Yeah.
problem.
I totally get it. Yep.
Yep. Yep.
Yep. All right. Well, so you spent some time at Build, and you've been going to Build for a couple years, right?
Yeah, I've been a bunch of times. Yeah.
You've been more than me. I've only been the one build, and I went to the first build and got that experience. Never went back. So how's
It's totally different than your local conference or regional conference experience. It's a different animal entirely.
what big takeaways did you get from build?
So it's kind of interesting. I am not your typical Build attendee. I don't really go to a lot of sessions, and I definitely don't go to the keynote, mostly because there's just too many people, and it's all recorded. It's stuff that I can watch later. So the really interesting parts of Build for me, besides like I get to connect with a whole bunch of old friends and see folks I don't get to see very often and that kind of stuff, is they have a really great expo hall. And in the expo hall, you'll have teams from Microsoft, engineers and PMs that set up booths, and they're there for 3-4 days, and you can actually interact with them. You can see new products and discover things that you'd never heard of before. And so I spend virtually all my time at Build. I spend in the expo hall, and so I saw a few kind of cool things that I wasn't aware of. Azure Maps, if you're doing any kind of geospatial stuff, Azure Maps is, I want to say it's a new thing. What I mean is it's new to me. I have no idea how long it's been around. I remember the old Bing Maps stuff.
Yeah.
But Azure Maps is like an API oriented mapping experience where you pass it, I guess through JSON, through a regular API call, you pass it a whole bunch of geo information, I assume shape files and that kind of stuff, and it does all the rendering and things for you kind of on the fly.
Oh,
Sort of
yeah.
sort of like an API version of Esri or something, So it's that was kind of interesting. And we're doing some geospatial work, or are planning to in the coming months, and so I'm probably going to experiment with that. My real big takeaway, and you'll see by the end of today's talk, I spend all my time in big data stuff these days. And so my huge takeaway is this fairly new thing just released in February called Azure Data Explorer, which has nothing to do with Azure Storage Explorer. So the naming, as frequently happens in these things, has gotten some people not understanding what it does, myself included, until I said, I spent almost a day. It feels like over the course of 3 days, I spent almost a day's worth of time with the Data Explorer team. And what it is an ad hoc query environment for insane amounts of data. So the canonical example, they always have that one example they show in every demo to everyone. They have all of the GitHub event data from 2016 to today, and it's in live streaming, so it's still up to, every 3 minutes they get an update of more data. The data set is currently 1.5 billion rows, over 3.5 terabytes of data, and they're running these really complex analytics queries against them in sub-second performance.
Oh, wow.
I know it blows your mind when you see it. And so, those are the kinds of things that are interesting. The fact that people like me have to do crap like that.
No, what's depressing is they're able to do that. And I have a regular old CRUD application, and I want to return 1,000 rows, and that query takes 3 seconds. And it's wait a second. what's the problem here?
Yeah,
Like,
they are. Well,
what am I doing
yeah,
wrong?
yeah. So there could be many things that you're doing wrong, but at the
It's
same
just me.
time, it's totally just you.
It's
That
totally
that
just me.
never happens for anyone else ever.
Nope.
But anyway, so those are the kind, and there were a few other things sort of in that family. You know, like I'm investigating Databricks. It's not something I'm excited about. Databricks is another. It's a Spark based, and so Spark is this underlying thread. If for folks who may not be familiar with what Spark is, it is a in-memory optimized version of Hadoop. Hadoop being the kind of classic big data analytics platform, and most of these things, actually all of these things, operate over effectively text files as their data store. So there's but it's this there's a whole industry around Hadoop, and Spark has become the preferred flavor of Hadoop. There are a bunch of those in this MapReduce universe, and the reason is because Spark does everything in memory, so it like loads these massive amounts of data into RAM, which makes your query and your performance time go much faster. It also makes your hardware more expensive and all that kind of stuff, So, but Spark is really something that Microsoft is taking hold of. So there's a Spark undercurrent now to many of the platforms. Databricks is explicitly Spark. Even Data Factory with the new Azure Data Factory data flow service, the engine underneath that is Spark. And then there are a couple other Spark shows up in a couple other of those products. So Spark is something to keep your eye on. And again, Databricks is explicitly a Spark experience. And then also kind of stemming out of that is a thing called notebooks. So notebooks are a way to, I think of it as executable documentation. So a notebook, again, a lot of the stuff comes out of the open source world, right? So Jupyter notebooks, Jupyter with a Y, is the one that's been around for a while, and the one that Databricks supports. But what that allows you to do is write chunks of code in line with documentation and graphics and even output. So like let's say you have a chunk of code that that does a lookup against the table. It'll display that table and then actually caches the results. So the next time you open the notebook, the data is still there. You don't have to run the query again. And then you string these code blocks together, and you can either run them independently or you can run them, the entire script end to end. And within Databricks, those chunks can all be different languages. So you're not limited to a single language, and Databricks and Spark in general supports Scala and Python and R. One of you asked about takeaways from build. The other thing is that they've now GA'd .NET in Spark, right? So there's a way to. It's still early, it's still version 1 stuff. It feels a little kludgy, but eventually, I think it'll become a first-class citizen. That's their goal, is to make .NET a first-class citizen within the larger Spark universe.
Nice.
That was another really cool thing that came out of build. And so again, for my takes, it's all in the big data space. And then there's tons. Of course, there are tons and tons of what I think of as regular app development things that would. That I didn't pay a whole lot of attention to just because it's not what I do day to day anymore. So,
well, wow.
Yeah,
So
but
that was
data.
just day one, right? Day one.
Yeah, that
Just
was
day
before
one.
lunch. That was before lunch. So, yeah. So
Oh,
there's
wow.
there's just a lot of really cool stuff happening.
Well, very cool. Well, let's go ahead and dive into your discussion about being an Azure Polyglot. And I know you and I have had this discussion many times before, so it's cool to see it kind of formalized into a larger discussion. So, anyone out there watching live, just feel free to ask questions along the way, and I'll interrupt Joel in mid sentence to ask your question. No worries. But with that, Joel, go ahead and take over.
Okay. Well, let me share my screen then.
All right, got your screen.
Okay. It looks okay to you? It's blinky on my screen.
It is kind of blinking in and out.
All right, let me stop sharing and I'll just try to restart it real quick.
All right.
And actually, I will also turn off my webcam to see if that helps a little bit with the throughput.
Doesn't hurt. All right.
Okay, that looks better. That looks better to me.
Okay. Yep. Looks good here too.
Great. So, yeah, as Kevin mentioned, he and I have had this conversation a little bit, and it's something that's sort of been stewing in the back of my mind over the last year or so. Again, I've moved from application development into this big data stuff. I'm still a developer, right? It's just a different flavor of development and maybe some different goals and different customer bases and all that kind of stuff. But I actually gave a workshop at the Atlanta Azure Data Fest on building real world pipelines, and we're going to see a little bit of what that kind of looks like as well. And in the development of that and in the conversation around I came up with this idea of being an Azure Polyglot because when you start really discussing it, and when you're in the trenches day to day and you're working on one piece or another piece, you don't really think about it. But when you step back and take that 10,000 foot view of what you've built, you realize all the different things, all the different services and the pieces and the parts that you had to pull together, that you had to go and learn individually about, that you had to not become an expert. I don't want to claim to be an expert at any of this stuff, right? And you don't, and I don't want people to think that being a polyglot means that you have to know everything, that you have to know all the different tools and tricks and that kind of stuff. But there is certainly an awareness of it and a willingness to stop and experiment with new things and to learn new syntaxes and that kind of stuff. And so that's sort of a very high level view of what I think of as an Azure Polyglot. Right? It's not, it's just more to be beholden to one thing. So the definition of a polyglot is someone who knows or uses several languages. I'm just replacing the term languages with things, services, syntaxes. Right? I'm taking languages to be a very broad term in this conversation. But that's what we're after, right? Is I can no longer be the C# guy. I was the blend guy for a long time. I can no longer just do blend. I can no longer just do ASP.NET. That's not enough anymore. If you're going to compete in this cloud environment, then you have to really have a lot of tentacles out into a lot of different areas. So my brief history of software development, and then I was thinking, okay, that sounds like I'm I'm going to go through all the eons of software development. It's really more accurately a brief history of my software development. So I started, like a lot of folks my age, in monolithic development. And it's kind of interesting that I say my age because I honestly wonder if, if newer developers and folks coming into the industry today, if they've ever actually experienced what it means to be a monolithic developer. My example is that I started in IBM AS400 land, which has one programming language, actually technically has two, but we don't care about the other one. There's one programming language that we built all of our stuff in called RPG. It's Report Program Generator. It literally dates back to the 60s, but people are still building applications and things with it today. And it's this really interesting, tight business programming language, right? There's no graphics support. Or wasn't. I shouldn't speak like this like I'm still into it because it's been years since I've played with it. But at the time, it's all 24/80 green screen development, and everything that you saw on the screen was one program, and that program encompassed the UI, it encompassed the business logic, it encompassed the data access layer, and I shouldn't even call it a layer because there was no separation between programming and database. One of the things I had to learn when I came into into object-oriented development, I started in Java and then moved over to .NET, was that the concept of talking to a database is not native to those languages, right? It was a whole other skill set, and you had to include other libraries to be able to maybe run OLADB or ODBC connections, and then later with .NET, we had some better things, but they were still, it was like this whole specialty for a while where talking to the database was not a native skill for, say, a C# developer. Well, in RPG, the very first thing you do in every RPG program is open file, and by file they mean database table. So it's a totally different way of developing software. And then as I moved out into Java and .NET, I brought those habits with me because it's what I knew. And this is the other, we all do this. You know what you know, and when you try to learn something new, you try to apply what you knew about the old stuff to the new stuff. And that's actually I have a very simple example of that later. But that's a problem as well. So we kind of have to try and break that mindset of constantly bringing our baggage along with us to the new things that we're tackling. But this is what, monolithic development, it still goes on today. A lot of like your banking software and that kind of stuff still runs on those kinds of environments. And that's where I got started in software. And so there's a really nice aspect to monolithic development, which is that you kind of have this protective cocoon of, I know these two things, I know them really well, and I can get everything that I need to get done within those two things. And it's really comforting, and you're not constantly battling, learning new things and incorporating new concepts. And so it's sort of comforting in that way. And it's easy to fall into the trap of staying with what you're comfortable with as well. And if you're going to be a true polyglot, that's not really an acceptable practice, right? It's not going to serve you very well. So it grew out of that eventually as I started learning a little bit more about how software is built, and kind of the classic in-tier development. So we started having separation of concerns. Our code's broken up into, I've got a layer of code that I'll call it the server layer. That's really kind of thinking sort of specific to web development. But if we were doing desktop development, just think of that as your business layer. I shouldn't really say server layer. I should say business layer. So you had your business logic layer, and then you had a layer that talked to the database, right? And so it had all the things that it had to do, and what that looked like morphed over time, again, from straight database connections to ORMs, and utilities of that nature. But the concept of the data layer is still there. And then your UI layer, of course, could be just about anything. When you're talking about kind of classic desktop development, we're looking at web forms, we're looking at WPF. Today, UWP is a thing. It is, by the way, UWP is still a thing. You asked me about build. I am not making this up. I was walking through the Expo Center, and the Expo Center also had these little theaters where people would sit and watch presentations, these little short, kind of like lightning talk style presentations given by the product teams. And I'm walking through and I look over, and one of the product teams is giving a UWP talk. So UWP is still a thing, it's sort of, people are sort of thinking it's dead, and that's not true. They wouldn't spend any of those resources on it if it was really dead, right? Anyway, sorry, just a quick aside there since we're talking about build. But so your UI layer is separated from your data layer, is separated from your business layer, except in practice, many times, that stuff was all still resident in, say, one Visual Studio solution, right? So you might have different projects for each of the layers, and you're technically doing separation of concerns, but we're still cocooning ourselves in one IDE, right? And I'm not saying that always happened, but you can kind of look back and say, I did that a lot. I tried the whole thing where you wrote your data layer in one project, and then you consumed the DLL in another project, and then you ran into all kinds of other problems. And deployments were tough, and so. But anyway, so in-tier development is still kind of, it's quasi monolithic, right? It felt it still felt monolithic, even though we were breaking our code up into more discrete chunks. And we did that for a long time in the web. And then I'm trying to come up with this term, Wild West development. And Wild West isn't really accurate because that really should have been before any of these other things. If you have a kind of a linear mindset. But what I really mean by that is now we just, we sort of do whatever it takes. And a lot of the times we're now consuming third-party APIs that I have no control over. I just want the data. I can't touch it. I'm relying on something like Azure Active Directory for my security. So I'm not building an authentication service anymore. I'm just consuming another service. Maybe I'm doing a website. Maybe I'm doing an iPhone app. And it's not different, not terribly different than what we're going to talk about with Azure and cloud development. But I don't necessarily have to learn new things. I'm just consuming new things, right? So I don't really think of things in terms of layers anymore. If I'm doing Wild West development, I'm just taking whatever parts I can find and kind of cobbling together an application or a solution. And all of that stuff is really what I'm going to lump all that together into app development. Again, it doesn't really matter what kind of app that we're talking about. It all sort of applies. And my real realization is that apps are not enough anymore, right? So we run into these really interesting kind of complex problems that we never had to deal with before. Big data is the thing that really opened this up for me. And there's a big data app assets and things available to lots of people. So if you're running a website, if you're processing telemetry data, or if your application is relying on IoT data or something, all of those things have big data behind them, right? And it becomes difficult. How do you process streaming telemetry data on your app and use it to inform your app's development or to let your users know what's going on, say, in their account or what have you? So apps aren't even enough of a silo anymore. All that stuff we talked about before really is kind of about app development. And what I want us to start thinking about is solution development. And these sort of holistic end-to-end solutions. And then on top of that, if we thought about physical infrastructure going back to the way that we used to do things, if I go back to my in monolithic development, it was really all one machine. In end-tier development, it was typically all one network. So even if you push that up to the cloud, but maybe you're running VMs, or even if you're doing that in Azure and it's an Azure app service, and it's talking to using Entity Framework that's connected to a SQL Server database, and you're delivering, your HTML, CSS, and JavaScript, that's still kind of one bucket of things, right? Maybe you've moved to the cloud, or maybe you're still self-hosting. This in-tier development section in my personal career was the most challenging because we were a super small company, and it really required me to get hands-on with things that even today that I struggle with, that I'm not really comfortable with, setting up and configuring servers and networks and domains and all of those kind of things that I don't want to do those anymore. Matter of fact, I don't. I haven't had to do those in quite a while. But I know there's plenty of developers out there that are still dealing in on-premise environments. And that's, there's a physical aspect to these things that we're talking about as well. And any time that a developer spends on infrastructure is time lost, productivity time lost in developing apps or services, right? So those previous conversations about tiers, let's replace the concept of tiers with a concept of a service. So in tier becomes in services. and I don't care how many services it takes for me to create my solution. That's what the N and N tier means, right? As many services. I just take as many as I need. And since I'm not managing the infrastructure of those, most of them I can pay for on a cost basis. So I only pay for the consumption. No, I'm sorry, a consumption basis. So I only pay for what I use. So also, unlike having the old infrastructure where if I wanted to stand up a server to play with Postgres, I had to have a server. I had to buy a server, right? Maybe Postgres was free, but the server sure wasn't. And the person who knew how to maintain it, me, or even if I hired somebody else, that person's not free. And patches have to happen, and that time's not free. And there's a lot that you get, and hopefully there's no one on the call that I have to convince about the value of cloud services, right? But so that's really what we're thinking about here, is replacing that old concept of tiers with services. And so we're not thinking about software anymore. We're thinking about solutions. We're not, or apps rather. We're not thinking of apps anymore. We're thinking of solutions. We're not thinking of tiers anymore. We're thinking of services. And by services, I really mean, for the most part, PaaS services, right? So modern cloud solutions are collections of PaaS services, so platform as a service, where I'll just go in and use it, but they're black boxes to me. I don't have to know anything about configuring the hardware. In most cases, I don't have to select the operating system. I don't have to spend any time keeping those things up to date. That's all taken care of for me. So again, I'm leveraging as many of these things as possible to reduce the amount of work that I have to do. I like to think that a lazy developer is what you want. When I call myself a lazy developer, it doesn't mean that I don't want to do any work, although there are days when that's true. What it really means is I don't want to do the same work over and over and over again. So I want to automate things, and I want to, when I need to, I want to write some code that will do this replicatable process for me. PaaS services allow me to reuse services without maybe doing the same thing over and over again, from a Joel work perspective. Those PaaS services, there's a lot of different languages. Languages, again, being kind of a very generic term in this case. Different formats, different syntaxes, different rules. Not everything runs on C#. As much as I love C#, and that's still my all-time favorite programming language, I can't do everything that I need to do with C#. Or if I can, it's far more complicated than just doing the native thing, whatever that thing happens to be. So if you get comfortable kind of breaking out of that, and again, not pigeonholing ourselves into, and I've heard people say it, and I've thought it in the past, if I can't do it in C# and Visual Studio, I don't want to do it. Right? And that just can't really be true anymore. I have to let that go. Mentioning Visual Studio, right? The tools are changing. The IDEs are changing, and the style of development is changing. So from a tools perspective, I know a lot of folks are using VS Code now. A lot of web developers. I know, Kevin, I know that you're a big fan. I still like Visual Studio when I need a tool like that, just because it's what I've been using since 2003. And it's hard to let some things go. So I'm still, when I have to use an IDE, I'm still falling into Visual Studio. But more and more, especially when you talk about PaaS services, what you're seeing is a web interface for doing that work. And the reason, and I've heard it attributed to Scott Guthrie, is that if this is truly PaaS, and the platform is the thing that's the service, then being able to work with the platform should also be hosted, should also be accessible via the same web. So if I'm working with things in the portal, whenever possible, I should be able to work on that thing in the portal. And so that's a movement that we're starting to see, and I've got a couple examples of that coming up. And then we take all these disparate things, it's the pieces parts, and we cherry pick. I want this piece, and I want this Azure function, and I want this data factory, and I want this piece of C# code that runs in Azure Batch. And okay, they all do these independent tasks, and I'm going to plug them together, right, like Legos. And that is ultimately what I'm doing, right? Is I'm not passionate about software development. As you know, it shocks people sometimes when I say things like that. If I could get the things done that I need to get done and never write another line of code again, it wouldn't hurt me. I don't miss coding when I'm not coding. I use coding a lot, of course, because it's what I know and because it's the thing that will get my task done. But what I really want at the end of the day is I want the solution, right? I want the work to be done. I want the thing to work. And so sometimes that's using a service, and sometimes it's writing some custom code. And then, like the Legos in our example here, I'm just putting those things together to build my solution so that at the end of the day, I'm being productive. The work that I need to get done is getting done. And that's sort of the really high level overview of how I think of approaching Azure and cloud services and modern solutions development both at a really high level. I'm looking at the kind of down at the 10,000 foot view of how we do these things, but then I'm also way down at the individual Lego block level, where whatever that needs to be. So we've got this green piece of Lego right here in the middle. If that needs to be an Azure function, great. Let's make an Azure function. If this red thing over here needs to be a logic app, super. We'll plug in a logic app. So at the individual task level, that's another way to think of that. So with that being said, I'm going to switch over to the Azure Portal. I have a few things open to show you already. First of all, this is FriendDA, so if anyone sees this stuff, you shouldn't see anything secret in there. If you do, it's my fault. But I'm going to show you something real. So I've also kind of come to this realization as a longtime presenter that I dislike demoware. So I don't have any demoware. I think it would be more valuable for you to see something real. So I'm going to switch over to my Visual Studio, my browser here. And I'm just going to walk you through some of these pieces, and we're not going to get deep into the actual code for each of these things. Again, this is concept art, right? Where we're going to be talking about the building blocks and just demonstrating, again, in a real world production scenario, what it takes to create some kind of an end-to-end solution. So the overall thing that we're going to be looking at is ingesting large CSV files into an Azure Data Lake. Azure Data Lake is a big data analytics, data warehousing platform. Is actually the topic of my previous talk here on the show. And so if you're interested in that specifically, you can go and look at that. It is not something that is terribly friendly to work with outside of its own environment, right? So it's actually also a really good example of finding ways to integrate it into these larger pipelines. And we're going to think of this as a pipeline. And so the way that this works is the very first thing that happens is we get a new file upload. And when I say file, I'm thinking blobs. This is a CSV file, and we drop it into a blob container. And that blob container has some events that are registered against it. And if you're looking here in the portal, you can see that this particular container has 6 different webhooks, six different event grid listeners that are monitoring these particular containers for these particular file types, these particular extensions. And when they are created, it will fire this event. Now, one really nice thing, I talk about being a polyglot, you will find that there are certain things that are difficult to deal with that you don't particularly like. And those things are different for everybody. Right off the bat, my top 3 are PowerShell, which we will not see today. No PowerShell was harmed in the making of this demonstration. Azure Active Directory, which I'll talk about, but I won't show because that is kind of a sensitive thing. And then Event Grid. These are all things that, services that I've struggled with, services or tools that I've struggled with in the past. So these are Event Grid events, but what's really cool is that I didn't set them up. So the Azure team's done a really nice job whenever possible. And the one that you're going to see today is through Logic Apps. The same feature is available through Azure Data Factory as well. And that is where in the tool itself, I can simply say when this happens, in other words, in our case, when this blob is created, then do something. And that event actually is set up through Event Grid, but I didn't do it. The Logic Apps interface actually registered these events for me down here at the bottom. So I simply told the Logic app what I wanted, and it knows enough about Event Grid to go and set it up. And I literally did nothing. So that's kind of nice. You can, of course, set up Event Grid yourself. If you're doing some kind of streaming data or IoT data or something of that nature, you're probably going to become comfortable with Event Grid. And it's nice when that service is involved, but it's really nice when I don't have to do anything at all to take advantage of it. So what we're looking at here is the storage account, and I'm just validating that yes, there are events registered. And so if I were to take one of these containers and I drop a CSV file, and we'll do this one here, a text file, and this one in the bottom, we would a little bit, right? So in this particular container, when a TXT file shows up, it fires the storage account fires an event. That event is being listened to more accurately in the Logic app. It's set up as the trigger. So Logic apps, and you can see there's a whole bunch of them have run. We do this about every 6 to 8 weeks. So a bunch of them ran back in March. So this Logic app is set up on a trigger, and we can see that this trigger is an Azure Event Grid trigger. So when that thing fires, it will start this Logic app. So I'll just hop into Logic Apps Designer here. Hopefully it won't take very long to load. It usually doesn't, but when we do web presentations, Teams and Skype and things like this tool here, sometimes these screen loads are kind of slow. So bear with me for just a moment as this thing loads. Please, oh please. Okay, so while it's loading, I will tell you what you're going to see is that again, there's a trigger registered, and when that trigger fires, and that trigger is inside this code itself. So the trigger is not defined externally, it's actually defined within the workflow of the Logic app. And so you would see that. And then you would see that there's some things we need to do to parse the URL. So I need some information out of the URL. So when this event fires, it sends, it's a webhook, so it sends a JSON payload to whatever it is that's listening to it. And what's inside that JSON payload is the HTTP URL of the blob that got created. And this is really distressing. Come on. And so inside that payload is that HTTP URL, and I need to parse that HTTP URL to pull out some information. So the file name, if we were to look in the storage account, the file name has information that I need in it. In our case, we're processing data by US state, and I need to grab the state code. Actually, what I really need to do first, before I can grab the state code, is I need to take that URL, I need to parse it out into its Azure storage components. So an Azure storage URL is comprised of the container, the account name, the container name, and the blob name, and I need those broken out into pieces. So I'm gonna move on from this, and hopefully it'll finish loading while we're looking at something else. So we'll check back on it shortly. But I have an Azure function that I wrote. So first of all, in the concept of a polyglot, right? I had to know enough about the event thing to set it up, and to confirm that it's firing. I then have to learn how to work with logic apps. So I have to learn this UI syntax, and then if that doesn't work, there's a JSON code view underneath it that I have to get comfortable with. So I have to learn the syntax of logic apps, and like any other tool, it has particular eccentricities. One very simple example, if we were to look at another one of these guys, I will also try and load the queue. All right, that was loaded before. It's not displaying now. So obviously my browser is not being very cooperative. Let's try something else real quick. All right, while that's loading, just again, an eccentricity of logic apps is there is, of course, a for each control loop, but by default, those are run in parallel. So if you have serial things that you have to do within the context of that for each loop, like say updating variables or something of that nature, you'll end up stepping on yourself, because how did you know that the default was parallel rather than sequential? And it's not obvious in the tool, and you have to go digging a little bit to find the setting for just that for each loop to turn it to sequential, right? So you kind of fight these little bitty things that are different across the services. This is Azure Functions. Azure Functions is a cloud-hosted, microservices-oriented environment. So you write these little code snippets. It's all consumption pricing, and you don't have to set up servers. You don't have to have an API, and you only pay for when it's actually executing, as opposed to 24/7 for hosting a classic, say, web API or something of that nature. There are also other triggers. I use mine for the most part based on HTTP triggers. And then here's one here that is Parse Storage URL. Whether or not we'll be able to actually see anything, because as we can see, our portal experience is not being terribly helpful at the moment. That's fantastic. But so this function app then takes that HTTP URL and parses it into those component pieces that I was talking about. So it sends back a JSON payload that has the container name and the account name and the blob name. So here we are. We can't actually see the code for it. It was published through Visual Studio. But again, that is a little bit of C#, unless you want to do JavaScript, unless you want to do Python, right? So you can do all those things, and nothing else cares what the actual language of the function app itself is. So function apps are really great little building blocks. You can see this is kind of my standard library of function apps that we use in a bunch of our different services. Send mail, so how many things do you have that have to send emails? I have a lot of them. I send emails from web apps. I send emails from logic apps. I send emails from data factories. And so we created a function app that handles all of our sending, our mail sending in one place. Get pipeline status would be, if this one would resolve, would be the one that you would see there. This is a great argument for taking screenshots of everything that you expect to be available live when you're presenting. All right, we'll try one more time, and if it doesn't show up, I'm not going to spend a lot of time waiting for it. So then at the end of this, after we've gotten the information out, so like I said, we get the account, the container, and the blob name, and then I take that blob name, and I actually have to parse the blob name itself to locate the U.S. state ID, the state code, and that state code And this event then actually gets registered in a queue. Now we're using SQL Server for our queue, which means there's a stored procedure call down here. And so there's several different reasons why we do that. But so there's yet another thing that we're pulling into the fray is, right, of course, SQL Server and stored procedures, which connect really nicely and natively in Logic apps, very easy to use, function apps as well. The data factories as well. And then that queues a job up in SQL Server. And that job is then listened to by another Logic app. That Logic app goes and finds all the jobs. And this one, if we could get it to resolve, which I'm not counting on, this one has one of those for each loops in it that I was talking about, where you could go and see the parallel or the sequential flag is turned off. And then within each one of those, that calls, the task at hand is to execute a data factory. So a data factory is another Azure PaaS service that's used for building pipelines, data pipelines. So here's an example. This is the one that particular job would execute. And in our case, this data factory is a collection of dependent USQL scripts. USQL, yet another language or syntax that we had to learn, is the language of Azure Data Lake Analytics. It is unique. It's the only place you can use it is Azure Data Lake Analytics, and it's a really great combination of T-SQL and C#. So in order to execute it externally, we had to call it from Data Factory, and so this Data Factory calls this one first and waits for it to finish, and then calls another USQL script, and it's passing parameters, which is an interesting animal because USQL doesn't have the concept of parameters, and yet I have to be able to send. So here, this data factory has a parameter, two of them, of the blob name that we ingested, and the state code that we ingested for this particular job, and so it has to pass those to the USQL script. And if we look in the USQL script under the script section, and the scripts are also not hosted in Data Lake. They have to be hosted in Azure Blob Storage. So within Data Factory, you have to be able to set connections using this concept of linked services. And linked services has its own kind of set of vagaries and problems. The biggest of which that we've run into recently is setting up a thing called service principals in Azure Active Directory so that Data Factory can communicate with some of these other PaaS services. Service principals are a real pain. Azure Active Directory is a real pain. That's a whole other thing that you have to get comfortable with, or at least be able to kind of bludgeon into service, right? That's where I always end up with service principals. They're getting better. A service principal is technically an app registration that really acts like a user, but you never log in with it, right? It's a service to service communication mechanism, authorization mechanism. And it's very difficult to get set up and working properly. There's a lot of moving parts to that. And so some services require service principals like Data Lake and like Azure Data Explorer, which is where we're going to end up in this conversation, and the new cool thing that I was talking about with Kevin earlier. So, so right away, if you start thinking about where we are right now, we have Blob Storage, Event Grid, Logic Apps, Function Apps, Data Factory, managed by Azure Active Directory, talking to Azure Data Lake Analytics account, executing stored procedures against the SQL Server. So I've counted 8 major services that we've discussed at this point, right? So if you were just a SQL guy, you wouldn't be able to build a solution like this, right? If you were just a C# guy, you wouldn't be able to build a solution like this. If you were just a web developer, right? You're just not all these things. It takes a certain mentality to start picking and choosing and learning at least the fundamentals of many, many different services. Data Factory was one of the things that kind of opened up that world for me, because as you go through here and look, Azure Batch is another one. Azure Batch is custom code. So I can fall back on C#. I can write console apps that are deployed at runtime against a virtual machine account that's basically virtual machine on demand. And I can execute custom code that way. It also does not handle parameters. So because you don't, it's a headless console app. So if you need to pass parameters, there's a whole different thing that you have to do. So you've been writing console apps for the last 15 years, Joel. That should be easy. It is, until I got to the point where I had to figure out how Data Factory passes parameters because it's not a traditional way. Right. So it's just this constant churn of change and services. Databricks, I was talking about, is a new service, and so several different ways you can execute Databricks pipelines. Data Lake Analytics is the USQL thing that you're looking at here. If we get into general, what we're looking at are kind of just basic things. So I can call HTTP. Matter of fact, before they included Azure Function support, that's what we did, is we called our Azure Functions through the traditional web activity. I can call stored procedures through this activity. I can execute other pipelines, which is something that we used to do before we instituted this job queue system. So we had Data Factory pipelines calling other Data Factory pipelines. What we do now is, if we get to the end of this chain of USQL events or activities, I always say they're dependent because step 2 requires step 1 to finish first. And then step 3 requires step 2, and step 4 requires step 3, and step 5 requires step 4. And then finally, I'm done. And what am I going to do? So this is just a logging routine that we have here, but I'm calling a stored procedure. And then I call another stored procedure, and these two are running in parallel. You can tell that by the 2 little green lines there. This stored procedure queues up another job. So while I have dependent scripts inside of this Data Factory pipeline, I actually have another Data Factory whose execution is dependent on this pipeline's completeness, success. So when this pipeline succeeds, I queue another job, and that's where, again, okay, just never resolved. That's where we have another logic app whose job is to look at the queue. It's actually the same one that kicked off this one, but it's going to find a different job, which goes through another series. It has a different series of Azure functions that it has to call. And those Azure functions, the last one is to execute a Data Factory. And it calls a different Data Factory entirely. So this, and by the way, you'll notice that if you look up here at the icons, we're no longer in the portal. So Azure Data Factory is one of those services that I was talking about earlier, where we're starting to see really high-end editing services that are cloud or that are web-based. So this UI is entirely web-based. You used to develop Data Factory pipelines in Visual Studio, and you don't really do that anymore. You do it here in this tool instead. It's still tied into source control. So we look up here, we'll see that we are storing all of our code, the actual JSON code behind this in source control, and so we still have access to those things. And then there's also, if we start looking forward and start looking at brand new technologies, there's this new concept of a data flow. And I love the acronym sometimes. It's ADF-DF, Azure Data Factory Data Flow, which is a mouthful. And I don't have an example of that. I don't think I have one. Yeah, I don't have an example of a data flow because we haven't gotten it. I was really just learning about it last week. But a data flow, so let me back up just 1 second. These pipelines that we're looking at, Data Factory is most accurately discussed as what we call an orchestrator. So it's orchestrating this collection of tasks, this collection of activities. It's not actually processing the data. So the data that is involved in this step is not inside of this pipeline. I always said the Data Factory is kind of lazy, which is probably why I like it, because I love lazy. All it's doing is saying, oh, hey, ADLA, Data Lake analytics account, I've got some work for you, and here's the script I want you to run, and here's the parameters I want you to run on, and then it's hands off. And it does that for virtually everything. The exception is the copy activity, where there's some server involved in the background that moves the data around. But these activities are not like SSIS workflows. Because the data is not present. It doesn't move from box to box to box. Data flows, on the other hand, is exactly like SSIS in that regard. When you get into a data flow, you're actually working on the data itself. So you're doing very much SSIS work. And I apologize if anyone on the call is not familiar with SSIS, but it actually does do the opposite. The data is physically present, and the little boxes that we're talking about within a data flow are actually pushing the data around. They're changing the data. They're appending columns. They're doing some analytics work. They're doing all. It's actually working on the data itself. So a data flow, you can think of it as an SSIS competitor within the confines of Data Factory. And that is, in fact, an activity. I could add a data flow activity to a pipeline. So what I foresee in the future is that we'll probably have some pipelines whose sole activity is a data flow. And then the data flow will actually handle the workload. And a lot of ours look like this. They're getting simpler over time because I'm getting better at designing and architecting these processes. I have another data factory, which I won't try and load because, as we've seen, we're having some. See, and now I'm not even I'm just getting nothing. So I don't want to move off of this screen. So again, that's Data Factory, and that's registering a job that executes another Data Factory. And then I am going to try to change over to copy to ADX test. So Data Lake, one of the problems of Data Lake, it houses very large data. We have, I don't know, 300 or 400 terabytes of data in our Data Lake. It does not have the concept of ad hoc queries. So it makes doing any kind of research against that data, it's not a great user experience because you have to write scripts that output CSV files to Blob Storage, and then you have to go and look at the CSV files. And what if all you wanted was a count of the rows that are in a particular table or for a particular state or something of that nature? It's really clunky for that kind of work. And there's a perfectly fine argument to be made that says, well, that's not what it's meant to do, and that's very true. However, that's a big problem that we have. And I mentioned earlier, the most exciting thing for me that came out of Build was Azure Data Explorer. So Azure Data Explorer is both of those things. It is a big data repository with a awesome ad hoc query engine built in. And it has connectors for Power BI, and you can, I believe, you can even you can even query it through C# code. There's a .NET SDK. Yeah, so it's again on that concept of constantly looking at what's next and constantly adding a new tool to the mix. Data Explorer is that tool for us. So what I have here is an example where we've loaded some data into this L2 data table, and it's got 693 columns in this table. And right now we have it loaded for, I think, four states. We're in the process. I'm actually in the process of writing a data factory to load more states in. But so we have some written in here for testing. And as you can see, the query syntax is quite different than SQL. And it's quite different than Entity Framework. And it's its own thing, right? So there's not only is there another physical mechanism for storage, not only is there a whole other tool that I had to go and configure, and there is a little bit of configuration in a Data Explorer environment where you have to pick the server level and the number of servers, so you manage your scale out and your scale up. So there's a little bit of configuration, still very small in the grand scheme of things, and much smaller than even an Azure Databricks, which is a fully hosted environment that you still have to do a lot of configuration with. So here we are trying to put another tool in, and so I ran this, and I believe I'll try to run a count. I don't actually have to remove that code to be able to do that. So we'll just do. I can't remember if I think it doesn't need that. I'm just going to try and run this guy here. And again, something odd going on with my connection. It is running though. It never takes this long. I'm going to blame this on. Yeah, so it took 1.5 seconds. Yeah, there's almost 4 million rows in here, and I did this query again, 693 columns, and I did this query, and I did not. There's no indexes, there's no views, there's nothing, none of that kind of stuff in here. So this is a really impressive tool, and it returned that query. We saw it in the previous results. It returned that query in less than 3 seconds. And normally it's actually faster than that. So I am at the 3 o'clock mark, so I will probably stop yakking, but that just sort of gives you an overview of what Joel's life is like these days. But again, we counted, so if we add this guy, we've got 9 major technologies that we're talking about in just this brief span of time.
Awesome. Well,
okay.
We have a couple folks. We have a couple folks in the chat. If there are any questions before we wrap up, now is the time. All right.
I'm not interesting enough for questions.
Yeah, the chat is silent.
Yeah, I did a Fritz. Fritz was doing C# Fritz was doing his Twitch thing at Build. And people were asking all kinds of questions of his guests and stuff, and I did a session with him, and I'm all hyped up and excited about this stuff, and it was just crickets at the end of the at the end of the talk. Like nobody asked a single question. I'm like, okay, I'm not wanted here anymore.
All right,
I will just take my ball and go home.
What you're saying is you're the common denominator, so it's a you problem. It's not a.
It's totally a me problem. It's absolutely a me problem. But hey, I as always, I had fun talking about myself. So
absolutely. Well, Andy, our friend Andy out there, just says you rock, Joel. Great presentation.
Oh, thanks, Andy. Can I, Andy? Can I give a? I don't know if I can talk about that. Never mind. If Andy wants to talk about it, he can talk about it. He knows what I'm talking about.
He can come on the show and talk about it.
He can come on the show. He should come on the show and talk about
wink, it. Wink, wink, nod, nod. Well, alrighty. Well, Joel, let's go back to our videos.
Okay.
So we can say a proper goodbye to everyone.
Should I stop sharing? I'll stop sharing.
Yes. Alrighty. Well, so no other questions in the chat, so we'll just go and wrap it up there. But thank you so much, Joel, for hanging out with us today. This will be put up on YouTube early next week for all to enjoy, whoever wants to come back and watch. So if you're watching the replay and you have a question, just leave a comment below. I will go grab Joel and say, go answer the comment.
Yeah, and you'll have to do that. Yeah.
But with that, we'll see you all in a couple more weeks for the next Swift Kick show. Thank you all for watching.
Thanks for having me, Kevin.
No problem.